During human development, have you ever wondered how one cell becomes a multitude of cells? And these multitude of cells specialize and give rise to structures like skeletal muscle so that we can move, dance, and do everything that we need to do in order to function. Well, that's exactly what my lab studies, how one cell becomes a multitude of cells, and those cells specialize and give rise to structures like somites. Somites are specialized packages of cells that will undergo certain changes like cellular rotation in order to form muscle cells. And I in particular study one protein that aids in this cellular rotation process, and that protein is filamentous actin or F-actin. So what is filamentous actin? Well, F-actin is a protein that actually helps hold and shape a cell as it undergoes cellular rotation so that it can form muscle. And how I visualized this was I took frog embryos, grew them to a particular stage where I can see somites form. I fixed them, I cross-sectioned them, so I took a cross-section and cut them in half, and I stained for their particular protein, F-actin. And then I took a big microscope and I took all of my images. And actually what I found was really surprising. As cells start to undergo rotation, they demand its own machinery and say, hey, I need more F-actin so that I can undergo cellular rotation and maintain my shape at the same time. And so this is really cool because we now know that as the cell undergoes rotation, that when it demands more of this protein, and this protein may aid in maintaining its shape, we know that we can then count on this protein to maybe play a large role in cellular rotation and forming muscles, and so that we can move, dance, and do everything that we need to do in order to function.